Today, we will learn MPLS VPN subscribers access Internet. We have known that private subscribers can communicate with each other by using MPLS VPN. Generally, MPLS VPN users also need to access the Internet. How to realize it and reserve the VPN service at the same time. This course will introduce several ways to do this. Upon completion of this course, I hope you will be able to understand how MPLS VPN users access the Internet via the ISP or via the MPLS VPN backbone or via different interfaces between CE and PE. Firstly, let's see the contents of this course. In this course, there are 3 parts. The first part is Internet access via the ISP. The second part is Internet access via the MPLS VPN backbone. The third part is Internet access via different interfaces between CE and PE. Now, let's learn the first part, Internet access via the ISP. Many VPN sites will need to be able to access the public Internet, as well as to access other VPN sites. The Internet service may be provided by the same carrier who provides the MPLS VPN service or by the other carrier. There are many ways of Internet access of the MPLS VPN user, such as Internet access via the ISP, Internet access via the static route routing and the MPLS VPN backbone, Internet access via sub-interfaces or dual physical links. This slide describes the realization principle of Internet access via the ISP. Looking at this topology, in the network topology, CEA and CEB respectively connect to Site A and Site B in VPN A. Site A connected to CEA access the Internet through the firewall and route A, while Site B connected to CEB access the Internet through CEA. It shows that the Internet service and MPLS VPN service are provided by different carriers. The considerations of the implementation in this mode are as follows. Between CEA and PEA, CEB and PEB, we use eBGP to distribute routes. On CEA, it is required to configure a default route to the firewall. And on the VPN instance VPN A in PEA, it also needs to configure a default route to CEA. This route in the VPN instance VPN A in PEA will be distributed to PEB through MP-IBGP. Then the VPN instance VPN A in PEB will learn a default route through MP-IBGP, and it will distribute it to CEB through eBGP. So the user of the site connected to CEB can access the Internet through this default route. The firewall connected to the central site CEA provides the security and the net service for the user of VPN A. The advantage of this mode is that it can be more conveniently managed because all the sites of VPN A will consider CEA as the egress router. So it can be called central access, which is widely used in the practical application. The disadvantage is that there may be one or more remote sites have other internet connections. So several default routes may be installed in the VPN instance VPN-A, and it may lead to suboptimal routes. Now let's see the detailed realization process and the configuration of this way. On CEA, we configure a default route to the next hop firewall. The command on CEA is IP route static 0.0.0.0 10.1.1.6, and then the CEA can get to the firewall. On PEA, we also need to configure a default route to the next hop CEA between the VPN user and the internet. The command is PEA IP route static VPN instance VPN-A 0.0.0.0 10.1.1.2. This command is used to transmit the internet service packets to the CEA. So when PA receives the packets destined for internet, it sends packet to CEA and makes CEA as the exit to internet. After the configuration just mentioned on PEA, let's see PEA VPN instance VPN routing table. We use the command display IP routing table VPN instance VPN-A, and then we can see that a default route originated by the VPN instance and its next hop IP address is 10.1.1.2. This IP address is used for the interface, which connects to PEA on CEA. The protocol of this default route is static. In order to distribute the static default route on PEA to PEB, we need to configure MP-BGP between PEA and PEB. Now let's see the configuration of MP-BGP. Entering the BGP view, using the command BGP100 to enable BGP on PEA, and then using the command IPv4 family VPN instance VPN-A to enter the BGP VPN instance view. Using the command default route imported to allow BGP to import the default route. The next, using the command import route static to import the static default route, and achieve the function of importing the default route from BGP in conjunction with the command above. Here, we must pay attention to the command default route imported. If we want to import the static default route into BGP, first we must use this command, and then the command import route static can take effect. What about the command network? If we use the command network on NE40E to import the static default route into BGP, do we need to use the command default route imported? When you have hands-on practice, you can have a try, and then you can know the result. After the configuration on PEA, using the command display BGP VPN v4 VPN instance VPN-A routing table, we can see that a default route is originated in the BGP VPN v4 routing table. It means we import the static default route into BGP successfully. We can also see some detailed information of the default route. The local BGP router ID is 1.1.1.1. Local AS number is 100. The ext community attribute is 10021. The route is advertised to CEA. IP address is 10.1.1.2 and advertised to its VPN v4 peer PEB. IP address is 3.3.3.3. So PEA distributes the VPN v4 default route, carrying RT attribute to PEB through MPI BGP. When PEB receives the default route from PEA through MPI BGP, after checking the RT attribute, PEB adds the route to its VPN instance VPN routing table. If we use the command display BGP VPN v4 VPN instance VPNA routing table on PEB, we can see that PEB receives the VPN v4 default route, whose next hop is PEA through MPI BGP. Using the command display IP routing table VPN instance VPNA on PEB, we can see that PEB installs the default route which is received through MPI BGP into the VPN instance VPNA. Because we configure eBGP routing protocol between PEB and CEB, so PEB can distribute 0.0.0.0 to CEB through eBGP. And CEB receives the default route. We can use the command to see the IP routing table of CEB. Using the command display IP routing table on CEB, we can see that the next hop of the default route is PEB. The protocol of this route is BGP. Now, CEB can use this default route to forward the packet destined for the Internet. As the figure shows, suppose that the users of the network segment 10.1.5.0 on CEA and 10.1.6.0 on CEB need to access the Internet. And the firewall needs to be configured net, which is used to convert the VPN users' private addresses into the public addresses. Then the static route to the net address pool is required to be configured on RTA. Firstly, let's configure the firewall. Creating ACL 3000, enter ACL 3000 view. Configuring the ACL rules to match the private address of the users of Site A and Site B. Rule 5. Permit IP source 10.1.5.0 0.0.0.255. Rule 10. Permit IP source 10.1.6.0 0.0.0.255. And then, using the command quit to return to system view, configuring net address group. To configure the public address pool of net. Configuring interface S1 to enter interface S1 view. Using the command net outbound 3000 address group 1 to configure net at the outbound interface. Secondly, let's configure the RTA. The configuration on RTA is very simple. Configuring IP router static 100.100.99.0, 255.255.255.0, 100.100.100.1 in the system view to configure the static route to the net address group. After the configuration above are done, the users of every site of VPN A, including HQ of Company A and the branch of Company A, can access other sites and the Internet. Okay, we have learned the first solution for MPLS VPN users to access the Internet. Now, let's learn the second part, Internet access via the MPLS VPN backbone. Look at this topology. This topology is similar to the topology of Internet access via the ISP. For this topology, the difference is MPLS VPN user access the Internet through MPLS VPN backbone, not through ISP. Here, PEA is considered as the central PE accessing the Internet, and the Site A connected to CEA and Site B connected to CEB access the Internet through PEA. We use BGP to distribute route between PEA and RTA. The considerations of the implementation in this mode are as follows. The user of VPN Site A, which requests to access the Internet, needs to use the public IP address. If the user uses the private IP, the IP should be translated into the public one through NAT on the route CEA. In the public routing table on PEA, there is a route to VPN user's network segment, whose next hop directs to the interface connecting the PEA to CEA. And this route is used to forward the packet, which is from the Internet and whose source address is the public IP address to the VPN user. Furthermore, it should be imported into the IGP in the public network or BGP in order to ensure that all the other routers in the public network know how to reach the VPN user. In PEA's VPN instance, there is a default route to the Internet, whose next hop directs to the Internet gateway RTA, which is connected to PEA. This route is used to forward the packet whose destination is the Internet to the next hop, which is the public address. It should be imported into the routing protocol run in the VPN instance to distribute to CE, in order to ensure that CE know how to forward the packet to the Internet. PE can use the default route we just mentioned in step 3, as well as exchange all or part of routes with RTA. If the router PA needs to be considered the memory requirements and the CPU load, the command network used to distribute the user's routes in conjunction with the route filtering technique is recommended. First, we will discuss how the user of CEA accesses the Internet. Let's see the configuration of PEA. The first command, IP route static VPN instance VPN A 0.0.0.0 0.0.0.0, 100.100.100.2 public. It is used to configure the default route from the VPN user to the Internet, whose next hop is the public address 100.100.100.2. The keyword public expresses that the next hop address is resolved by the public routing table, but the VPN instance. BGP 100 IPv4 family VPN instance VPNA. These two commands are used to enter BGP VPN instance VPNA view. In the IPv6 family VPN instance VPNA view, the commands default route imported and import route static are used to import the default route just configured into BGP, run in the VPN instance VPNA, and distribute it to CEA through eBGP. After the configurations, CEA will originate a BGP default route whose next hop is PEA. Then CEA can forward the packet to the Internet, passing through PEA. Now, using the command display IP routing table VPN instance VPNA on PEA, we can see that there is a default route whose next hop is RTA in VPN instance VPNA. When all the configurations above are achieved, the packet to the Internet from the user of CEA will forward correctly. However, how is the packet from the Internet to the user forwarded? Supposing that the user whose IP address is 10.1.5.1 and belongs to Site A connect to CEA requires to access the Internet. First, because the user uses a private address to access the Internet, CEA should be configured net. To configure net to translate the address of the packet whose source IP address is 10.1.5.0 and the destination IP address is 100.100.100.0. Here we configure the public address pool range as from 111.1.1.1 to 111.1.1.10 by using the command net address pool. It is required to configure route to the net public address pool on PEA. The configuration is PEA IP router static 111.1.1.2 24 serial 2. This command is used to configure the outbound interface to the user network segment as serial 2. If the link between CEA and PEA is Ethernet, it needs to specify the next hop IP address 10.1.1.2 instead of serial 2. In addition, the public network router RTA is required to configure the route to the net public address pool as well. We can use the network command on PEA to distribute the user's network segment to the eBGP peer RTA. PEA BGP 100 PEA BGP network 111.1.1.0 255.255.255.0. It can be also done by the configuration of the static route on RTA. RTA IP route static 111 11.1.1.2, 24, 100.100.100.1. After the configurations, the user of CEA, which address is 10.1.5.1, can access other sites of the VPN as well as the Internet. Now we will discuss how the user of CEB access the Internet. Supposing that the user of CEB, whose address is 111.1.1.1, needs to access the Internet. If the user uses a private IP address, it is similar to the example we have mentioned to configure NAT. And then a default route to PEB should be configured. We can apply the mode used by CEA, which is to distribute the default route to CEB through eBGP on PEB. It is similar to PA that PEB also needs to configure a default route whose next hop is the IP address 100.100.100.2 of RTA in VPN instance. PEB IP route static VPN instance VPNA 0.0.0.0 0.0.0.0 100.100.100.2 public. It is required to configure PEA to distribute the network segment of the interface of RTA to PEB through BGP. Then there will be a route of the network segment in the routing table in PEB. The configurations are PEA BGP 100, PEA BGP network 100.100.100.030. In addition, P also needs the route to the Internet. There are several ways of doing this. If the egress router PEA is configured to distribute an OSPF default route, P will learn the default route to the Internet, whose next hop is PEA. It can be also configured that the route policy on PEA import the route learned from the eBGP RTA into OSPF accordingly. Then P will learn associate route to the Internet. The configurations above are used to forward the packet of the user of CEB to the Internet. After the configurations, on PEB, we use the command display IP routing table. We can see that there is a route to the public network 100.100.100.0, whose next hop is PEA. On PEB, we use the command display IP routing table VPN instance VPNA. We can see that there is a default route to the Internet, whose next hop is the interface 100.100.100.2 of RTA in VPN instance VPNA. On P, we can see that there is a default route to the Internet too. It is needed to configure a route to forward CEB's packet to the Internet when CEB receives the packet from the Internet to its user. There are several ways to configure the route. Look at this slide. There is an example of the configuration. On PEB, we use the command IP route static to configure default route to the user of CEB, which next hop is CEB on PEB. On PEB, the commands PEB BGP 100 and PEB BGP network 111.1.1.1.32 are used to configure BGP on PEB to distribute the route to the VPN user's network segment to PEA. In order to ensure that PEA has the route to the VPN user's network segment. Because RTA is the eBGP peer of PEA, RTA will also learn the route to the VPN user. In addition, P should have the route to the VPN user as well. It can be realized by the static route configuration. For example, on P, using the command IP route static 0.0.0.0 11.11.11.1, or on PEA, using OSPF default route advertise to advertise default route automatically. On PEA, we can use the command PEA BGP display IP routing table 111.1.1.1 to see that PEA has learned the routing information of the VPN user from PEB through MPI BGP, whose next hop is PEB. On RTA, display IP routing table, RTA has also learned the route to the VPN user, whose next hop is PEA. So PEA and RTA can get to the network 111.1.1.1. The mask length is 32. On CEB, we can use the command tracert to check whether the user of CEB can access the internet. We can see that CEB can access the internet through PEB, P, PEA, and RTA. We can also see all the hops. Now, let's see the last part. Internet access via different interfaces between CE and PE. As the figure shown, there are two links between CEB and PEB. The user of CEB uses these two different links to access the user of CEA and the Internet. When the protocols of data link layer, such as frame relay and ATM, support the logic subinterface, we can use different logic subinterfaces. When the protocols of data link layer do not support the logic subinterface, we should use different physical interfaces. When we use the logic subinterface, we can economize the physical link resources. About this topology, PEB uses two different interfaces to set up two different BGP sessions with CEB. One of these two interfaces is bound with a VPN instance, so that it can be used to provide the MPLS VPN services, while the other one is used to set up a BGP session and provide the Internet service. The configuration on CEB and PEB are very simple. Let's see the configuration on PEB. Using the commands PEB BGP 100 and PEB BGP peer 12.1.1.2 S number 65420 to provide the Internet service. PEB BGP IPv4 family VPN instance VPN-A, PEB BGP VPN-A, peer 10.1.2.2 S number 65420 are used to provide the VPN service. After finishing the entire necessary configuration, the routing information of the VPN user of CEB is distributed from PEB to PEA through the extended attributes carried by MPI-BGP. Then PEA will install them in the VPN instance VPN-A. And the routing information of the Internet user of CEB will be distributed to PEA through MPI-BGP. Moreover, to the public network. I think this mode is very simple. VPN service packets and Internet service packets are using the different links. When VPN users use a private IP address to access the Internet, we also need the NAT technology on the link, which provides the Internet service, in order to translate the private IP address into public IP address. Do you have any questions about this mode? We have finished this course. I think all of you can understand how MPLS VPN users access the Internet. Now, there is a simple question. Which ways can be used by MPLS VPN users to access the Internet? 3 ways, okay? The first one is Internet access via the ISP. The second one is Internet access via the static default routing and the MPLS VPN backbone. The third one is Internet access via sub-interface or dual physical links. Thank you.